This conference will now be recorded.
Hi, good morning everyone. Today let us see different types of services. I think we have already discussed about customer IP, and then we have discussed about node port, and then we have discussed about the load balancer. So yesterday while we are discussing about load balancer, we have seen that a node port is also enabled by default. Okay, so there is a way to disable our node port allocation for your load balancer service. Okay. For that, let us try to follow the procedure and let's see how it will try to disable your node port creation when you are trying to create a load balancer service. Okay. So for that, there are two things which you have to follow. One is you have to specify certain parameter in the service YAML file, and another parameter is you need to enable this particular feature gate in the API server. Okay. So to enable this particular feature gate, yesterday we have seen how to do it. Just a second. Um, Feature gate, right? Yeah. Features which you can enable, disable at any point of time in the API server. So this is what you have to specify like this. Okay. Whichever you want to use, that you have to specify that parameter is equal to true or false, whatever it is. Okay. So by default, that is not enabled. So you have to enable it. What is that parameter? Service LB node port control. Okay. It should be set to false. Okay. And this is set to false inside this particular existing, and you have to explicitly remove the node ports entry in the service port allocation, and you must enable this particular feature gate to use this particular field. Okay, so in order to use this particular field, I have to enable this one. Okay, so to enable that, I have to set it to true actually. Okay, so let me show you that parameter. Let me search for that and show you. Yes, this is how it is. You can see here, right? Service load balancer. Now you can see it is beta version. Okay, so now in this particular 1.22 release is beta version, and it is set to true. Earlier it is set to false. What does it mean? That is nothing but default. Where is that? Let me show you the cave. You can see what stage it is, what stage of release it is. Okay, since which version until which version. Okay, so this version was since the alpha beta version. Right now in 1.22 it is. Maybe in the next version, maybe it will be a general available in the sense no need to worry from your end. Okay, by default it might be enabled or it might be disabled. Okay, so no need to add from your end. Okay, so default now it is set to true. Okay, that is what we have to mention. Okay, so what we have to do, let us see. First of all, I will show you by adding this parameter in the service YAML file and see will that make any sense or not. Okay, where is it? So kubectl, yesterday I deleted all those deployments which we have created. Let me try to create it once again. So kubectl create -f services and then deployment, right? Let it be running. These are running right now. So which service we are using earlier? Service, let's say I'm using load balancer, right? LB. So my metal LB is running. That's fine. So here, which parameter I need to specify? Let's see. So under spec, it is expecting this particular parameter to be specified and set to false. Okay. So if you have it, sorry, this is specified. Let's try to create it. So kubectl create f services LB create. Now if you look at your service which was created, let's say, you can see now it doesn't have anything like this. So since it is a beta version, now for you it is not needed to worry about this particular feature gate. Okay, this is set to true by default. Earlier it was set to false actually. Okay, So in the alpha version release of 1.20 or 1.21, when I used actually, what I need to do, I need to go to the API server manifest file, I need to enable the feature gate, and I need to add this parameter is set to true. Okay, so this is what I need to do only. Now in the beta version of 1.22 release, no need to do it. Okay, this is 1.22 release documentation, and the version which I am using also it is 1.22. Okay, get notes. You can see here, right? 1.22.2. It's almost the latest version. Now you can see there is nothing like a node port which is enabled. Okay, which means that now if I go to the node, I cannot give this 8080, right? So let's go and see. Where is my node? Node IP address is this. From yesterday and today, it got changed, right? Let me try to give 8080. I see only 8080 port number over there. Okay, so nothing is going on, right? And but still I can access this particular IP with 8080 port number, right? Or let's try to give this. It's not working. So which means that I need to go ahead with 8080, which is working fine. And I can also even go with cluster IP. Okay, so this is our expectation right now. Simple. Earlier we used to do some complex things to disable that particular node port for a load balancer. Now it is so easy. Just you specify your parameter in the service YAML file. So this file, and you just need to create it. That's it. Okay. I'll add this particular parameter in the documentation. So in this load balancer metal LB, I'll be adding that as well. Okay. So how to disable your node port creation while you are doing with this. Okay. So that I will be adding it in this documentation. So this is about this, like whatever we have created this load balancer and all, this is fine. Okay, so now let's try to remove this particular things. I will remove only the service. Okay, so kubectl delete svc shortcut name. Okay, my hyphen Linux. So this got deleted successfully. So nothing will be available related to service. So if you want to access these applications, you have to use pod IP address right now. Okay. So let us try to think in a situation where there is an external application, which is, let's say your front end application is running on Kubernetes cluster. Okay. And let's say your backend application is running on your on premises, maybe your data center or somewhere. It is running your backend application, which is nothing but maybe MySQL, PostgreSQL, or any other database related application in the backend. Okay. It's running on your cluster. You don't want to run that in the Kubernetes cluster or any other cloud or somewhere, whatever it is. What could be the reason? But it is not related to your Kubernetes. That application is not running in your Kubernetes cluster. It is running as an external source. Now, how an application in my cluster can communicate to that particular cluster? There are multiple ways. Whether you can hard code, that's one thing. Like you for a front end application, one more thing what I want to do is, like, I don't want to tell where is my destination actually. I don't want to give that particular destination public IP address, or I don't want to expose the details. Okay, so that's what I want to do. So in order to do that, I don't want my front end application to know about my back end application. Okay, but still there need to be a communication. Let's say in your front end application, you will update only, let's say you are trying to create a service. Okay, for example, this service, you will be specifying a parameter called external name. In this external name, you will be writing your destination, means your backend application where it is running. Obviously it will be a domain, right? Public domain, where you can reach from anywhere in the geographical location. Okay, you will not give a public IP address because that IP address might change, maybe. Okay, so what will happen if my front end application wants to talk to this particular application right now? It will use this particular service DNS. So if I use my hyphen service dot svc dot, sorry, default dot svc dot cluster dot local, it will reach to this particular domain. That's how the redirection is added. So in my front end application, always I will be adding this particular my hyphen service DNS entries to communicate to the backend application. So it will come to this particular service, and this service will try to divert the traffic to this particular external domain. Okay, so this is called as external name. So let me try to use this particular example. Here I have one example which is like so the DevOps, right? This is the website which I have right now. Okay, I want to point to this. It is running on 80 port number. That's fine for me. Just I want to point to this particular domain. Okay, so my maybe front end application, whatever it is. Okay, so how to do it? Here I have to change it to, let's say for example, dot com. Okay, simple. Now this is okay. This is what I have created. So let me take this example. Simple. This particular service, whoever uses it, they will reach to that particular domain. Okay, simple. Whoever uses this particular service, they will reach to that particular domain. Okay, so let's create a service. Okay, so external name, external service, this is what you can see. Fine. Okay, I'm okay with this. kubectl create -f services external name. Okay, so this got created. kubectl get all -o wide. Okay, now you can see here it is external name. You don't have anything like cluster IP right now. For this, it doesn't create any cluster IP. Okay, now you have this particular domain to be pointed. Now what does it mean? Any application which is running in my Kubernetes cluster, if they want to communicate to this particular domain, they can directly use this particular service, my hyphen service dot default dot svc dot cluster dot local. Let us try to see it. So kubectl run test hyphen pod hyphen image equal to um, details. Okay, and then I have to give something like hyphen rm hyphen pi bash. Takes 1 minute maybe. Okay, now if I run ns lookup on this particular domain, my hyphen service, okay, you can see here it is pointed to this particular domain or not. Now this is like canonical name, cname, which is nothing but if someone is trying to reach this particular domain, they will redirect to this particular sudhidevops.com. That's how it is. You can see the IP address and you can see the name. Okay, you can see 192.71.232.3. This is a public domain, a public IP address actually. Okay, in class C network. Okay, this is how it is. Yeah, any questions?
Hello, hi Sudhir.
Yeah.
What is the use case of this type of thing?
So this is a like this is a normal what do you say, we don't use it in this in production servers or somewhere frequently or in some particular situations. Okay, it could be where if you don't want your front-end application to know about your back-end application, I want to hide it. Okay, I don't want to expose my back-end applications to my front-end application where they are running, and they are not running in my cluster, they are running somewhere else. Okay, if you want these two functionalities to be done, then we have to use this particular approach. Okay, your application should not be exposed to your front-end application, and if it is running in somewhere else, okay, then we have to use this particular service, or else no need to use at all. Okay, there could be some situation people might ask like, why can't I use my front-end application with directly with this particular domain? Yes, we can use it. Okay,
Can we specify IP address here?
where no, No.
External name.
For that we have external IP. Okay, there is one more service, right? That service is called as external IP. There you can specify your
Okay.
IP address, public
Okay.
IP address. Okay.
And can we specify port name as well? In
Yeah,
on
yeah.
which port? Okay.
Yeah, it's, let's say if your sudhidevops.com is running on different port number, right? Then what
Mm-hmm.
you have to do, let me exit from here. Okay, your service which you have created, okay, you have to specify the port number here. Target
Okay.
port is always nothing but your destination.
Mm-hmm.
Okay, this port is nothing but related to your service. Okay, my service in the sense what? My hyphen service. For this service, what is the default port number? That is nothing but 80. Your target port number is this.
Mm-hmm.
Okay, it is listening also 80. I know that it is default 80 port number, right? Any domain by default.
Okay.
Okay. If it
Sudhir,
is
I
running in a
have.
different domain,
Mhm.
running in a different port number, you have to specify that. Okay.
Okay. Sudhir, I have also one question from Docker. It is a very quick question.
Okay. Yeah, go ahead.
Okay. So I wrote uh, a command on chat box, if you can see.
Okay. Okay, Docker
Uh,
run. Okay. Okay.
mhm. So what is the
Your
purpose of the
environment
last
variables
the
slash
last
data.
slash
Okay.
data?
Huh.
So what is the purpose of this directory
See,
slash data?
here you're passing two commands actually. One is server and then space slash data. Before that, it is a image name, right?
Yeah, image
Uh,
name and
in
then
new.
container name.
No, 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 no. It's not like that. Okay. Your container name, you have not specified anywhere. Okay. It will create with some random name. Okay. You haven't specified anything name. You have specified docker run hyphen p. You are exposing the port numbers inside the container with your node port. Okay. After that, you are passing two environment variables. One is access key and one is
Hmm.
secret key. Okay. After that, you are passing your image name, which is nothing but minio slash minio. Okay. After
Hmm.
that, you are passing some particular commands. These commands are
Okay.
actually maybe command or it could be a arguments to your application. Once a container is created, this could be an arguments which will be passed to your utility which is running inside the container, or it could be a command directly itself. Server space slash data. Okay.
Okay. Okay. I confused with the name. I was thinking that server is the name of the container. Oh,
No, no, no.
sorry.
It's not that. We generally, if
Mhm.
you want to specify the name, we give hyphen hyphen name.
Hyphen
Okay.
hyphen name. Okay.
Yeah.
Sorry. Okay. Thank you.
So this is all about your external name. But if you want to create an external IP, first let me try to explain that. What is that exactly? What does it mean and how to use it? Okay. So I hope this point is clear. How to disable the node port allocation for a load balancer. You can just always refer this documentation until it is a general available. You have to follow this. You have to specify this particular parameter in your configuration file of your service. Okay. When you are using a load balancer. Okay. Now let me scroll up and let me see load balancer. This node port. This is done for us. Then I have to go for, yeah, network load balancer. This one is different. Yeah, external name is done, right? See here in this example, what is showing is nothing but service of a type external name maps to a service to a DNS name. Simple. Okay. Not a typically selector such as my service or Cassandra. You specify the service with the external name parameter. Okay. Whenever you want your service to be communicated to the external DNS name, simple. You have to go for this particular option as we discussed. Okay. Uh, let's say the next, yeah, external IP. Here we have to specify your external IP to which you want to assign to this particular service actually. Okay, but here the problem is this IP address should be available. Here you can read this. If there are external IPs that route to one or more cluster nodes, okay, the Kubernetes services can be exposed to those external IPs. What does it mean? Let's say you have some nodes in your cluster. Any one of the node is having some IP address with a public IP address. Okay, that is not yet used by any application or you are not using for any purpose. Okay, that was intentionally assigned to a node. okay, to use for later purpose or maybe for Kubernetes purpose only. Now you can use that particular public IP address, okay, to be allocated to your service. Now whenever you create a service with the external IP with the uh, like the IP address what you have specified, now your service will be reachable from outside. Outside in the sense, since people can reach to this particular public IP address from anywhere in the geographical location, now if they want to access the application behind this particular service, okay, whatever the ports it is binded, those ports can be reachable. Simple. Okay, so that is how it is. In my case right now, I cannot use this particular external IP right now, but I will be using this 10.244.0 something like that, and I will try to use ping or some particular curl command to reach this particular service. But here, if you want to use this, that IP address should be there as an interface. Okay, let's see how is that possible. Let's see. Okay, let me first explain practically. If you have any doubts, we can re-execute this, or we can just recap the topic once again. External IP dot yaml. Now I will cannot use this. I will use some port IP address. Okay, 128 dot let's say o dot 128. Okay, I hope it is not used by anyone. But anyway, now this is 80 port number. What is my applications are running with? Is run my Nginx, right? Run my show hyphen labels. I just want to see the labels. Yeah, temp hyphen Nginx it is. Okay. App temp hyphen Nginx. Okay. Okay. Now, first of all, let me see with this IP address we can is do we have this IP address or not? Okay. So it is not reachable right now. Okay. Which means that either it is physically not available or virtual IP address is also not created. Physical in the sense like through Ethernet card. Okay. This is not available. It looks like this. See, this is your interface, right? Actual interface. This interface is having this particular IP address and other node is having 0.3. Okay, but you don't have that particular IP address. So let's see how this might solve our problem right now. Okay, so let us see that. So let me try to create this particular service. Now it's saying that it's already exists. Okay, services will already exist. Try to create. It got created successfully. So keep searching. Okay. Now if you see, there is another service which we have created with external. Where is that? Oh, where is that? Yeah, here it is. Okay. Here you can see it got created with this IP. Okay. Now is this reachable? Let's see. After creation, yes, it is reachable. Can someone tell me how is this reachable? Okay, earlier it was not reachable. Now we have created it. Okay, now we are using this external IP. Okay, Let me explain that. Okay, so if you watch carefully, this was handled by your kube-ipbs0. Okay, so what will happen, this interface will have this IP address. That's the reason this will be reachable. Okay, it should be from the same series what your node is having. See what your node is having, right? It should be that particular specific IP address. So this will be reachable from anywhere in the within the cluster or from outside the cluster. Okay, so this is how it is. So this is what we have to allocate your IP address. Generally what we will do, we will have either a separate interface for that particular IP address, or with this interface only it might have virtual IP. For this, see, for a single interface we can create multiple IP addresses, one main IP address and one multiple virtual IP addresses. Okay, so with that virtual IP addresses you can use it for your service as an external IP, and you can be reachable from outside, from anywhere. You will be reachable to that particular application. Okay, now if I go to my compute node, okay, let's go to my compute node and see whether I will be reachable from there or not. Your nodes are created on the same network. That is what you have to remember. Okay, what I'm using right now, if you execute IP space a command, you don't see anything like that, right? Here can you see that? Yes. So whenever you create a service with that particular external IP, obviously that is getting created on all the nodes. You can see here IPv0. Obviously if I try to use ping, it will be reachable 10.128.0.128. Done. Okay, so this is how it is. Okay, so in this way the IP addresses, virtual IP and virtual interfaces and all, this is how it is matched. Okay, so this is how we have to use external IP. We don't use it in production, this external IP, external names, these are rare cases that we use. Okay, but you have to know that we have this particular option as well. Okay, if you want to know something about this virtual IP implementation and all, how it is getting allocated and all, this is already written in this particular what do you say, documentation, official documentation of service itself. Okay, and this documentation only you will be using in your examination, whether it is CKA or CKS, whatever the CKAD, whatever the exam you try to write, always you have to follow this particular documentation for new changes or new modifications in the existing functionalities. Okay, so this is how it is. So in this way we can create these different types of services that we can use. And we have seen headless service as well. Sorry, headless service we have not seen. We have seen a service cluster IP and without selector and with selector. And then we have seen node port service, and we have seen load balancer service, and we have seen external IP service, and we have seen external name service. Okay, so these are the 5 types of services that we have seen right now. The only one service which is left is nothing but headless service. Okay, so what is this headless service? So headless service in the sense, a service which is created, okay, by default it will have its DNS name will be pointed to your service IP address, right? Let's say for example, let me create a simple one so that you will not get confused. Let me clean up everything. Delete -f services. Okay, now if you look at your all objects which are created and they are getting terminated, let us wait. Okay, almost done. This got cleaned up completely. Okay, now I want to create a service. Okay, that service I will be creating with the default option called cluster IP. Okay, so let's see how it looks. um, So let me create services. It doesn't need any labels. So here also it doesn't need anything. Output doesn't need protocol use selector app temp nginx. This is fine. So this is your default. Okay. Now this services with deployment object. Let me see if it is the same. Yeah. Okay. Done. Let me create once again. This is the default behavior. Okay. FNF services deployment. Done. Is also created, right? Let's verify first. Okay. Now this is running. Generally, we use this particular cluster IP. Now, what will happen to the DNS when you try to search for the DNS? Let me show you. So, when you try to see the DNS resolution for this particular domain, what is that? my-nginx dot default dot svc dot cluster dot local. It will point to this particular cluster IP. Okay, that's a default behavior, right? So ns lookup my-service. Oh, my-nginx it is. Sorry. Okay. Now you can see your DNS is pointing to this particular address, right? This is the default behavior, which is called as default cluster IP behavior. What we have now. What is this headless service? Headless service in the sense, and when you try to communicate to an application, we use this particular DNS name. This DNS name will point to this particular IP. From this IP, it will go to the backend ports. How many ports you have? It will do a load balancing to this particular ports. Now I don't want this particular procedure. Whenever someone is trying to reach to my DNS, directly that particular request should go directly to the ports. There should not be nothing like my A record. This DNS should not be pointing to this particular single IP address. Okay, I want this particular service to be pointed to this particular ports. How many ports I have? Tomorrow, if I recreate my pod, also automatically it should detect, and if it is changed or something happened, also it should detect. So my DNS should point to that particular pod IP addresses directly. I don't want this particular service to be pointed to this particular A record and then reach to that particular pod IP address. If you don't want like that, if your DNS should be pointing to directly to your pod IP addresses, then we have to use headless service. So how to create a headless service? Okay, so let us exit from here. Let me create a services cluster IP we have, right? For that only I will create headless. Okay, headless.yaml. Simple. Go to services, open the file. Simple thing, what is nothing but you have to write type, or we have to specify cluster IP none. Okay, so this is what you have to specify. You can see here actually headless service. You have to specify none. Okay, by default type is cluster IP. No need to specify type. Directly you can write cluster IP equal to none. Okay, so this is what I have written. Now see what happens. This is another service which I want to create. So the name which I want to give is headless-nginx. Okay, so let me create this service as well. Create -f services and then headless. Okay, so this was created. Now let me try to check for that. You see, now there are two services which are created. You can see the cluster IP is set to none. Okay, and you don't have any external IP. Nothing will be there. Okay, you don't have a cluster IP first of all. For this particular my-nginx, I have the cluster IP. Okay, where everybody can reach. Now, if I try to look the NS lookup for this particular domain, it will point to this particular IP, and this IP will do a load balancing to this particular 3 ports. Now, if you try to do an NS lookup to this particular domain, what will happen? Let us see. Okay. Okay. ns lookup. First is my hyphen nginx, right? See what happens. It looks like this, right? So if you use headless, you can see it's directly pointing to your pod IP addresses. You can see 192.168.101.80.79.78. Okay. So if you are using this particular service, it will directly point to your, what do you say, your IP addresses of your pod. So that's the benefit we get. Okay. So then that is how it is. Okay. So it is getting a response from the pod directly itself. There is no cluster IP in between, and that's how the load balancing is doing. It's not like that. Whenever you try to check for this, directly it will go to the pod. That's it. Okay. So that is how it is. So this is about your headless service. Okay. So if you want that particular situation, see where we have to use this is nothing but when you are using a concept called stateless applications, right? There we have to use this headless service. So we haven't discussed stateless application, stateless object actually. We discussed about pod, standalone pod. We discussed about replication controller, replica set, deployment, daemon set. We have discussed these 5 topics, but we have skipped one of the topic which is nothing but stateful set applications. Okay, when you are using stateful set applications, we have to use a service with a type called without headless service. Okay, so we should not mention a cluster IP. Okay, so there we have to use it. Then we will learn more examples about that. What is the intention, actual intention of using this particular headless service? Headless service is simple. If you try to reach to your domain, that particular DNS, it will directly point to your pod IP address. Okay, that's how it is. Yeah, someone is asking something. Okay, so in this headless service also we have with selector and without selector. Okay, so without selector means like if you want to use some external what do you say, it should not use my endpoints. Okay, then we have to use without selector. By default it is with selector, no need to explain more about this. Okay, so what is that? For headless service that defines a selector, endpoints control creates endpoints record in the API and modifies the DNS configuration to return the A record to point directly to the pod backing the service. That's it. If you want to point directly to the pod, then we use this particular headless service. Okay, that is intention. For headless service, the cluster IP is not allocated. Kubeproxy does not handle this service, and there is no load balancer or proxying done by the platform for them. Earlier, what we used to do, if you are using a service with a cluster IP or something, when you try to reach the DNS, it will go to the IP address. That IP address will take a help of kubeproxy, and kubeproxy will do a load balancing to your backend ports. But here it's not the case. Okay, so directly it will go to your pod IP addresses itself. So there is no load balancing which will be done. Okay, so that, and no load balancing as well as no proxying which will be done. Okay, so that's a benefit we get. How DNS is automatically configured depends upon whether the service has selector without selector. That's how it is. Okay, and that is, we have already know about it right now. Okay, and then anything else I want to discuss? Pushing services. These types we have discussed already: external IP, external name, load balancer, cluster IP, headless service, and all. Okay. So this is the entire information related to your services. Okay. Yeah. Any questions, please?
Yeah, Sudhir. So if we don't have any load balancing in these 3 ports, then means how if
See,
we
now your
mm,
service is directly pointing to your pod IP addresses. Your request is
mhm,
going, that request will go to one pod. No load balancing, right? So your request will go to that particular pod. If that pod is down, okay, if that pod is
mm,
down, your request will go to another pod because it is pointing to 3 pod IP addresses, right?
mhm,
Got it? If a connection is already established and if that pod is down, yes, that connection will have some interruption. Okay, but if your connection, see, you're directly pointing to your pod, there is no load balancing. That is straightforward answer. If there is no load balancing, when I try to reach to that particular DNS, how it will go to the 3 pods? It will not go to the 3 pods, it will go to only one of the pod. Okay, your request will go to only that particular pod all the time. Okay, if you want to change it, then we can change it also, or else if that particular pod is down, it will go to the next pod. Okay, when only that particular pod is not available. That's how the default behavior is of headless service. Where we need this particular approach for a stateful set application. What is the stateful set application? Let me explain that. There you will come across about this particular headless service once again. Okay. Right now remember that your headless service doesn't do any load balancing or proxying. Whenever you try to reach your DNS of your headless service, directly it will point to your pod IP addresses. How many you have? It will point to each and every pod IP addresses. Okay.
Okay, thank you.
Yeah. So with this, we are done with the service. The next topic is persistent volume and persistent volume claim. This I want to discuss tomorrow. I don't want to put it this in the same day itself. Okay. So for that, first of all, I have to recall about my volumes. What is the volumes? Again, I have to recall about that. What are the disadvantages we have? Then I will be talking about what is PV and PVC. Once this particular topic of PV, dynamic PVC and dynamic PV is, dynamic PV, static PV creation, and then PVC creation, and then storage class. Once I discuss about this particular topic, then we will be entering into stateful set application. Okay. Once this is done, then we can go to the further topics. Okay. So these two are major topics in the coming sessions actually. Okay. So today I would just want to wind up here itself. Okay, and then we can, if you have some time, you can just ask me a questions, or else we can wind up for today. Okay.